So this video is going to look at solving systems of linear equations, and this is just the first part where we'll look at how to make an augmented matrix. And eventually, all of your linear algebraic skills could land you a job in the graphical computer science area. Or maybe you're just doing it for fun, but understanding how to put something in an augmented matrix will help you do transformations like these. So, the way to solve an SLE is to put it in an augmented matrix and then perform row operations. We don't always deal with equations that just have two values or just two equations. Sometimes we deal with SLEs that have 5 values and 6 equations. It becomes too slow for humans and computers to perform calculations in the usual substitution method, which is why we use matrices. So let's say you've got 2 equations. You'd use the substitution method. It'd be easy enough to calculate the solution, but as you can see, you've got something a little bit more lengthy here, and your test paper is going to get messy. You're not going to have much time to complete the other questions on a test or an exam. So this is what my exercise book looks like when I use the substitution method on some lengthy equations. It's a bit hectic, and this is actually a much neater version. This is when you implement augmented matrices as well as row operations. You can simplify this to this within 2 steps instead of half a page, and that's nowhere near as complicated as this lot or this lot. So it's a great thing. In the real world, this calculation saves industries thousands of hours, days, and gets you movies and games that you know and love. So keep that in mind and make sure you understand the method so you can save thousands of hours in your job as well. So let's start simple. Let's say you want to convert the following system of linear equations to an augmented matrix. The first thing you want to do is to organize them. Align all equations on top of the other. In this case, not all the values are aligned in the same order, so make sure you rearrange them to be in descending alphabetical order. Organize them. This is a big thing. Like this. Next thing you want to do is check. Check that you have copied it correctly, and also to fill in any missing values. So these 2 equations don't have a z value, but this one does. So just put in 0 times z. Lastly, you want to augment. So now you can transform it into an augmented matrix. In the first column, place all the coefficients of x. In the second, the coefficients of y. And the third, the coefficients of z. Lastly, draw a vertical line to represent all of the equal sign of all the linear equations, and write the right-hand side values on the other side of the line. Sometimes it's not just one value, as you saw in my notes. Sometimes it can be up to 3 values, so it's important. So this is what you're going to get. As you can see, all the coefficients are in the first row of x and y and z respectively, and you've got 3 or 1 for the equal sign. And that's it. So just remember to organize, check, and then augment, and you can't go wrong.